that's a long discussion that we don't have time for today. So what is MSVR? MSVR has actually been around for quite some time. It started back in 2008 by Katie Masaris, if you know her. It was announced at Black Hat that year. And basically what we were finding was that cases that were reported to Microsoft as issues in Microsoft products and things that we were finding inside the company through our own testing were affecting many other companies in the industry. And we didn't have a process for taking those things that we knew inside Microsoft and handing them off to those other companies to get them addressed. So we developed MSVR as a way to improve that process. As part of that, we developed a number of different elements to help us coordinate with those third parties, some of them relatively not obvious. So again, this is not the MSRC, it is part of the MSRC, but it's about us going out rather than things coming into us. It's unrelated to our bounty programs. That's also handled within the MSRC, but by a separate team. And it's unrelated to the HackerOne program, which again we're affiliated with, run out of the MSRC, but not part of MSVR. What MSVR does do, and you'll probably hear me repeat this over and over, is take things found inside Microsoft and report them out to other companies. And one of the big reasons we do this is that most of the people who are finding security vulnerabilities inside Microsoft are not doing it as their primary job. We don't generally employ people to go off and test third-party products for the purpose of finding and reporting security vulnerabilities. So what we want to do is provide those people an easy conduit to get what they've found out to that third party, because what we had found in the past was that people who didn't have that easy conduit would either just not report the bug because it wasn't part of their job, or they would report the bug but they wouldn't spend much effort in following up. One of the things we'll talk about is that actually finding the right place to report the bug is a difficult challenge in many cases. And so we help with that. We have a big database of companies' security contacts, so we often know the right person to talk to at a particular company to get a bug fixed. And when we don't know, we have the resources to go find that, which often involves digging through sales channels, which we'll talk about in a second. But that takes a significant amount of energy. Our objectives here, number one, we want to get everyone on the same page. We have somebody in place in the MSVR program who's an expert in communicating about security vulnerabilities. What we had found before this program was that some developer in Windows may know nothing about the security industry, they may not know how to communicate securely, they may not know how to talk about an issue with a third party, and they might not have the interpersonal skills necessary to effectively coordinate with a third party. That can potentially cause damage to the third party company and to Microsoft, so we wanted to prevent that. So our program helps with that coordination, with the communication. It helps provide status updates. We can offload a lot of the back and forth about timelines from the person within Microsoft, the employee, to our program. And we can provide a lot more transparency to both sides about why we're doing what we're doing. Again, when an individual reports something, they may not have the time to go into the details of why they found that particular issue. We also have a space that we can use to inform our customers if our company finds and reports a very serious vulnerability that we think all of our customers need to know about. Now, consistent with Microsoft's coordinated vulnerability disclosure policy, we only publish these advisories after the vendor has released a fix, except in the case of active attacks, we might release an MSVR advisory. We've never actually done so, but generally speaking, this is a coordinated effort where we feel that there's some issue in a third-party product that needs particular attention. You don't see these too often, but we do put them out there occasionally. Part of the reason we do that is we want to ensure our people get credit. One of the issues we had in the past was it wasn't clear whether a vulnerability found at Microsoft would be something that you could receive public credit for or if you needed to remain anonymous. We'll get into some of the details around that, particularly around bounty programs. One of the reasons that we focus on third party is that third party is intrinsic to what Microsoft does. Windows, as you're probably aware, runs a ton of different third-party code, and so Microsoft does a lot of work testing that third-party code on our platforms. And as part of that work, we often find security vulnerabilities, and those security vulnerabilities represent a problem for our customers as well as for the customers of that third-party product. Many of the attacks that take place on Windows today are not leveraging a Windows problem at all, they're leveraging a problem in a third-party program. So we have an incentive to drive those vulnerabilities out of the ecosystem as much as we can. And this is not just for your classic PC software running on Windows desktop, but we have data centers that run all sorts of cloud software. Our data centers run Linux. We have all sorts of networking hardware in our data centers, so we're concerned about that. We have devices that include firmware, so we're concerned about that. And we have software stores that sell apps, and we're concerned about the reputation of the software in those stores. And a lot of the time when we find these vulnerabilities, it's actually a shared responsibility. So it's not just for third-party vulnerabilities that don't affect Microsoft. In fact, we use this program very often when we find vulnerabilities in protocols. So for example, if you guys remember the DNS flaw a few years ago that was going to blow up the whole internet, that was one of the reasons why MSVR was founded and funded, was to help deal with a situation like that where we need to work across the industry to solve a problem. We see this come up often in SSL protocol issues as well. Like the crime attack is one example. We also see that sometimes a pattern emerges at Microsoft that we find coming out across the entire industry. So we might determine that our developers are consistently making a significant mistake, and often when we do that, we will check to see if third-party programs are making the same mistake. And when we do find a problem that's kind of a general coding error, developer error, we sometimes use MSVR to get the word out that, hey, you industry should look into your software and fix these problems. So just to give you an idea of who we work with, it's a close approximation of every major company in the industry that produces software. You can read the list at your leisure, but basically we work with just about anybody you can think of, and this is only a partial list. Part of the reason why we do this is to ensure that we work with others the way we would like them to work with us. There are a lot of nuances in how you interact with a third party when reporting a vulnerability that can make a big difference in their ability to effectively address it. We are the recipients of a lot of poorly formatted reports, and it impedes our ability to get problems fixed. So we try to model the right behavior in our interactions with others and provide a good experience for them so that for example, when we report a bug to a third party, a lot of these companies are going to turn around and report bugs back to us in our software. We'd like them to see a good way to do it. One thing that's kind of a core goal of this program is we don't want Microsoft employees releasing zero-day vulnerabilities. This program helps provide them a conduit where they feel like they can get traction without having to go full public disclosure without a patch route. We also try to filter things so that the vendors we report to are not basically spammed or DOSed by us. We try to filter out low severity bugs. We try to filter out bugs that aren't going to reproduce, that aren't affecting a default configuration. Basically keep it interesting, the kind of thing that an attacker might actually use. We also try to make sure that the package we send over is useful to them. We often receive bugs that kind of say, open this doc and it crashes. And there's no indication of whether the crash is exploitable or why they think it's exploitable. There's no indication of how they produce the document. There's no indication of what kind of steps might lead someone to exploit the vulnerability. So we try and make sure when we report things that there's a very clear reproduction so that the vendor can basically follow the steps we give them and understand exactly how we hit the problem, why we think it's a security issue, and how it might be exploited. We also have a goal to basically make our employees feel good. In some regards, this is a carrot for people like Jeremy who find lots of security vulnerabilities. We want to help them out. We want to make them feel appreciated, supported, get their name out there, get them credit. One of the problems we found was that often vendors don't provide credit. So the MSVR program allows a way for Microsoft to provide our own finders credit when a third-party vendor doesn't want to do so. I mentioned securing our ecosystem as well. And then the last thing is, a lot of these vendors we wind up working with in a partnership relationship over time, and the fact that we're helping them make their software better builds a strong relationship between the company's security teams. And that even includes companies like Google that you might think of as adversarial to Microsoft. We certainly compete with Google very vigorously on a number of fronts, but we also cooperate in security. Who are these people? Well, Jeremy's one of them. Jeremy's in the first category. We have individual Microsoft employees who just like finding security bugs, kind of your classic hackers who just enjoy it. It's a hobby, it's creative, it's fun, and they find security vulnerabilities. Oftentimes it's particularly focused on software they use, and this is kind of who you generally think of as a security researcher. But we also have a couple of other categories that are probably more particular to Microsoft. We have product teams who do extensive work with third-party products as part of their own development process. So for example, when Office implemented a save as PDF function, they did a lot of testing to make sure that the PDFs they were saving would work properly with Adobe Reader. And in some cases, those PDFs might trigger a buffer overrun vulnerability. This is a hypothetical example. I don't actually know whether they found any buffer overruns in Reader, but it's the kind of situation where we are likely to find bugs because we might run tens, hundreds of thousands, millions of files through Reader. Some of them may actually produce a crash. It might be an exploitable crash. We needed a conduit to get those bugs to Adobe. Oftentimes, because these are part of very large formalized test passes, we generate a very large volume of bugs. So having a formal framework helps us prepare a company like Adobe that, hey, we're about to dump 1,000 bugs on you, get ready. And because we're also a large company, we know about project management and scheduling, and so we can give them the information they need to start allocating resources before we just give them a packet of 1,000 bugs, so that they're ready to act promptly on those discoveries as we make them. And in some cases, this is ongoing work. We have an AppCompat lab that tests our software with third-party products over time, every single month as we release security updates. So for many companies like Adobe that have really major software that we run a lot of tests with, we essentially prepare them that we're going to give them a stream of bugs over time. And then the last thing is, because our product teams do just about everything you can think of in software, we have a lot of one-offs. And we very often get a question along the lines of, hey, I found a bug in X, what do I do with it? And that's what we're here for, is to help those people who don't generally participate in the security process know what to do and handle that bug effectively. To be eligible for this program, the bugs have to be found by a Microsoft employee. It doesn't matter whether they are on their own time or on company time, although that does have some implications that I'll talk about in a second. They have to be important or critical on our SQL bug bar, which generally means interesting for an attacker. I'll give some examples here. And they have to affect Microsoft in some way. This is focused on securing our ecosystem. So while we certainly encourage our employees to report any, for example, iOS issues that they find, MSVR generally won't assist with those. It's mostly focused on stuff we use in some way. These are not really hard rules. It's mostly, our program is essentially staffed by one person, so we have to make some trade-offs in order to just ensure that that person can do their job effectively. We have some requirements. These are actually written into our employment agreement. Note that I'm not a lawyer, I'm a program manager, so none of this is legal advice, I'm not your lawyer, etc. We have a requirement that our employees are not allowed to release zero-day vulnerabilities. They're required to use coordinated vulnerability disclosure under all circumstances. For anybody who's unfamiliar, CVD is kind of the new name for responsible disclosure that allows for a lot more nuance and understanding and is less judgmental. But basically the idea is no posting to full disclosure without vendor permission. We also have a requirement that any vulnerability that you are going to report must be shared with MSVR. Basically our program tracks all of the security vulnerability reporting that's happening through Microsoft, or it's happening from Microsoft outbound, even if we aren't mediating that. If you found a bug on your personal time, you don't actually have to go through us, you just have to let us know. Basically that's just for our own visibility. In case there is some conflict, we need to be able to say that this is following the policy. And then the last interesting thing is we actually allow our employees to report through vuln brokers. If you found the bug on your own time, not using company equipment, we don't stop you from reporting that through Zero Day Initiative, for example, or another company that offers a bug bounty, or reporting directly to a company that offers a bug bounty. That's allowed. You can keep the money. Basically, we won't stop you from doing that. Again, you have to notify MSVR, but money's all yours. Okay, so how does this work? Step one is our internal researcher reports a bug to us. We have a form to make it real easy. Basically, what's the software? What do you think the severity is? What are the repro steps? Attach any repro files. Any other considerations, hit go. And this goes into a tracking database for us, and you can also just email us if you prefer, but people like the form. And this goes wrong when you don't report to us. So the whole reason we created this program is to prevent our employees going to full disclosure, but most of the time they come right to us just like we expect. And the second thing we do is make sure that the report is high quality. We review it to make sure everything is there. So do they give us details of a bug? Is the bug severe enough that we care about it? Do they have solid repro steps or a solid file? Ideally, they should have a stack trace. They should have a thorough analysis of all of the different products that might be affected. And really, we ask them to try and come up with any kind of suggestion for the vendor about a workaround or a code fix. Now, obviously, that's not always possible. But we try and give the vendor as much information as we possibly can. And we will actually go back and forth internally to get those things present before we reach out to the third party, so that when we do the reach out, the third party can hit the ground running. For example, we've seen this gone wrong when in reporting to us. We got a report that if you log into Windows and you have the number 8 in your password and you have numlock off and you start to use the number pad, you might switch focus because 8 corresponds to tab if you have numlock off. and then start typing your password to the username field. So this is the kind of bug that we've seen reported to us. That's not a really high quality bug. Like, this is not going to get fixed. It's not likely to be used by an attacker. And so MSVR would not report this bug. We would tell the finder, thanks, but no thanks. The third thing we do is we make sure that this bug doesn't affect us, because there's nothing worse than going out telling a third party they publish a patch and then your customer gets owned because you were vulnerable to that too. As far as I know, this has not actually happened to us, but we want to make sure that it doesn't. So before we report a bug, we see if it affects Microsoft as well. We won't necessarily hold the vulnerability report until we fix the issue, but we want to at least know whether we're affected. Partly because if we are affected, we're going to want to coordinate a simultaneous release with the third party, and it's best if those conversations start up front. So some examples: SSL, browser bugs, anything where we have shared tech or similar tech. So one thing, a problem that we had, again, a lot of these examples are either hypothetical or modified from real life to preserve the guilty who prefer not to be named. For example, some of our researchers went out and said, there's this problem that occurs in payment networks where you can report duplicate transactions and get paid multiple times. And they found it, they reported it to a couple of payment networks. What they didn't report it to is Microsoft's own payment network through Bing. And so it turned out that we were vulnerable to this problem. Oops. This is the kind of thing that MSVR is designed to prevent. The fourth step often turns out to be the hardest one. We look for the vendor security contact point, which should be something like security@vendor.com. Turns out that address often goes to their physical security office or to their sales office or the catch-all office. And a lot of the time, those people have no idea what to do with it. So we spend a lot of time trying to hunt down the right person at a company to contact. So the number one thing I would say, if you're out there working for a software vendor, please make sure that you have a security contact point posted clearly on your website. It doesn't take any time to do that. It will make your life a lot better if you find a vulnerability. So please do that. I'm thinking that because you guys are here, you probably have all done that already, but please do that. We tell them that we have something to report. We request their PGP key. Another thing we'd like to see is having your public key posted so that we can send you an encrypted email from the start. That's a little bit more of an ask since you actually have to have a PGP setup or an S-line setup and maintain that over time, roll your keys, etc. So that's not realistic for a lot of smaller companies, but at least hopefully you know what PGP is or what S-line is and how they work, because a lot of the time we reach out to people and they have no idea how these kind of basic email encryption technologies work, and we don't want to send them a clear text proof of concept that could be intercepted on the wire, so we always encrypt outbound, and sometimes, much of the time, that means we have to tell them how to install PGP and walk them through the steps. But once we get that, we send it to them. This often goes wrong in this sort of sales purgatory thing where we contact them, we've got a security vulnerability, they say, what's your customer ID? We say, we don't have one, we're trying to tell you about a bug in your software. They say, well, I'm sorry, without a customer ID, we can't help you. Sorry. Say, no, we are helping you. And then they say, thank you for contacting vendor, and then they just stop replying to us. So oftentimes we are unable to find a good contact, or we have to leverage some personal network or try some other company in the industry to see if they know someone. It can be really awful to break through this, and we see this all the time from companies that should know better. Once that's done, we enter this kind of monitoring stage where we just work through, this is pretty straightforward. What's the status? When's it going to be fixed? Any problems? Help resolve those issues. Keep everyone up to date. Now, where this one often goes wrong is the vendor just never tells us that they fixed it. We follow up. Somebody finally notices at the vendor company that we've been emailing them for 6 months. They say, oh yeah, we patched that thing a long time ago. Thanks. So hopefully that doesn't happen. Hopefully they tell us, they ship an update. We work with them to credit our researcher. A lot of companies simply aren't aware that credit is something that's supposed to be provided, so we help do a lot of education there. Sometimes it works, sometimes it doesn't. A lot of companies, the marketing department has to review everything, and they still view researchers as some kind of awful pirate-like people, and so they won't allow the credit to be approved, but we push that as much as we can. Unfortunately, we don't always win that one. When we have a particularly sensitive bug, we'll release a security advisory, an MSVR advisory, telling people to install it. You probably have never seen these before. They don't get nearly the same profile as our security advisories for our own products. There's a reason for that. Basically, we don't want to tell the world that the world's melting if the world isn't actually melting, and most of the time it isn't. So we don't really publish these very often. We do have a list that I'll talk about in a second that's sort of more low-key that we just created that may be more interesting to you. Again, we coordinate this with the vendor. This is not something that we're going to do if they don't want us to, if they haven't patched yet. This is in coordination with them. Now, the exception to that is if there are active attacks, we reserve the right to publish something, but we've never done that yet. And I should mention also, the Finder can release, once the vendor is patched, the Finder can release their own advisory, blog post, do a talk, and we've done a number of talks in that vein. So this is what our advisories look like. They're very similar to our Microsoft security advisories, but with a little bit less information. We mostly point to the vendor for their technical details. We also have, this is a recent addition, a short form acknowledgement where we basically say, thank you to Finder for reporting issue of this severity in this vendor's product. Here's a link to the vendor's site. This is a way for us to put our researchers' names out there. This one doesn't get a lot of traffic, but it might be interesting for you guys to just see the research that's coming out of Microsoft. So I would encourage everyone to check it out and just see the bugs that we're reporting there. And so for some examples of that, I'm going to turn it over to Jeremy to talk about the kinds of bugs that we report in this program.
So I have a few case studies here, as we mentioned earlier. The first one being Buggin libav codec. So this is a vulnerability, the MSVR 12017, which showed up actually through fuzzing VLC with WMA files, and we found out it was actually not a bug in VLC, but in the libav codec. So at this point, you start the triage stage, and okay, you found a crash. Is there any merit to it? Is there anything exploitable? What does it look like? So right off the bat, a lot of times, a lot of the tools that we use, the first step is, bang exploitable, what is it doing? This helps you figure out a little more automated way instead of manually triaging. So right off the bat for this one, write AV at libav codec plugin.dll. So from then on, you can see that it's in libav codec and not actually VLC, which is important when you're reporting the vulnerability because you want to get it to libav codec. You don't want to get to VLC because they're not writing the code for the product. You want to get it to the right person. So in this one, we did a diff to see what it changed. Highlighted a little bit, but if you can see the 01 was changed to 07. So just a simple mutation of the file caused this crash and potentially exploitable. So you can see it was changed to 7. What does that value mean? So there's a tool called Offiz, and it's free available. You can download it on the Microsoft website. It was made mostly for Microsoft Office to look at the file formats, because we produce a lot of really complicated file formats, and it gives you a view into what the values actually mean, and if you can see a template of what the values mean in the file, you can understand what's going wrong, how is it trying to interpret it when you have a crash. So this one, might not be able to see, but the number of channels actually changed in this one. So it changed from 1 to 7. And then after some research to seeing what container actually changed in the WMA file, we found out it was ASF. Looked up the number of channels in the ASF spec, which is a public spec on the internet. We found out it's a 16-bit value. It's a member of the WAV format EX structure, and as the name suggests, is the number of audio channels for the content. We also saw that it was interesting that changing it from 3 to 8 actually caused a crash, and then changing it to 9 had VLC display an error about how does it support WMA2. To actually learn more about even the other formats by changing values in the previous one. So I didn't show you a look at the stack trace, but I'll give you a couple of last instructions. Pop EBX and a call keyword pointer EBX plus 30. So it's pretty exploitable at that point once you control EBX. So for this one, package up the files in the MSVR, and then like David's talked about for the past bit now, handle the coordination, status updates, and we got it patched later that year after I discovered it. That was a successful case, and this is what the advisory looked like. This part of the ones, as you talked about, we were doing the one-liner credits now, but used to we had a more in-depth advisory. This is what the one for libav codec looked like. So you have the executive summary, mitigating factors, stuff to let users more aware of how to get around this bug if they can't patch the system for some reason, how they can work around it. Even. So the next one I want to talk about is in VMware. It's in VMware Player. And there's actually, it's in the OVF tool, so it's not in the main player part, but a default tool that's included in VMware. So this one I want to go about step by step of how I actually knew where to look for the bug. And so first you see step one, what if you're going to fuzz files or do manual testing or pen test something that has file formats, you want to know what it supports. You want to know which ones it supports and a little bit about the formats. So if you're familiar at all with VMware, you know it does VMX, BK, all the disk files. OVF, that one was a new one for me. I had never heard of OVF. So a quick open virtual machine format, just an excerpt, open, secure, portable, efficient, extensible format for packaging and distribution of virtual machines. Sounds interesting. Sounds like it has a lot of good stuff to change. So long didn't read, XML-based file for describing virtual machine data. Also very interesting. So first step, how do you even know how it even loads the OVF files? I found out, as I alluded to a little bit, that it didn't actually come from VMware Player.exe, the main executable for VMware Player. It came from the OVF tool, default tool packaged with VMware at the time. So it's actually opening up OVF tool, passing the file that you're giving to VMware, and giving it some parameters to load the file, or in this case, transform it into something VMware can understand. So this was a screenshot of actually going to the OVF tool directory, using its help, which was very helpful in understanding how it worked, and knowing a little bit more about how to actually find this bug. So once we have, so the first step before you can start trying to find the bugs, we know where to look for the bugs. We know what to execute, what parameters to pass it, and how to find this unexpected behavior that may have security implications. This is a quick look at the proof of concept that I'll show you a GUI display up here in a second. But this was just changing the OVF envelope in the XML file to %p. If you're not familiar with %p, it's a format specifier. So that kind of goes into the bug I found, which was a format string vulnerability in the OVF player. So we packaged up the POC, gave it to VMware Player, and as you can see, it's reading memory addresses from the OVF tool on the target machine. So this is the few steps I went through to first figure out how to find bugs in it, and then do the testing to find the bugs, and then package up a clean, basic proof of concept for it. And this was the advisory that we sent out for it. So the next one is a little different than the other two. It was submitted, honestly. It doesn't have a MSVR advisory listing or anything. Because this was a little different than the other two cases, it wasn't as successful, but you'll see why. So I submitted it as the BlackBerry Print-to-Go auth bypass. So what is BlackBerry Print-to-Go? Well, you can print documents from your computer to your playbook. So you can take something, hit print, and take along with you with your playbook. So install software on your PC and take whatever documents you want with you. This is their depiction of the playbook and how marking model works for it. So in order to send the documents to the playbook, you got to authenticate to the BlackBerry service. You have to log in using your BlackBerry ID. Then you encrypt the files and then find the device using its PIN. A few other steps aren't really important at this point, but the bug that I found was we could bypass the logging into the BlackBerry service. So we could perhaps print documents to the device without authenticating BlackBerry. Sounds interesting, right? So this is the model of how it would work. So this is the dialog you get when you open up Print-to-Go when you want to print something. So sign into BlackBerry, okay? Ran a tool, I'll just really open up TCP view, and I found that there was a listening service on port 1234. If you ever see a service on 1234, it's going to be interesting in any respect. There's not a lot of services that legitimately listen from that. So I had the dialog box open. I started a web browser, and I just happened to have the dialog box open. I wasn't even really testing that round at this point. Pointed it to this URL, which I might have found reversing or some way, and it continued to the next page. Did not need to log in to BlackBerry in order to use the service. So, in theory at this point, keep in mind I don't have a playbook, I can't really test this with the device, but at this point I'm thinking, okay, maybe the login procedure checks if it receives the data, but it doesn't do it well enough to know that if it's valid data or if it's coming from my web browser or if it's coming from the device, somewhere legitimate or not. It's not doing some check because obviously I just bypass login to continue on to the process of printing. You enter the pair with the device, give it the file name, where to print to, and then I would get this error. So at this point, I was thinking, it's hard to go further with this because I don't have a playbook. I don't know if it's giving me the error because I don't have a playbook and it's just failing to print to something, or if there's another check that may be stopping me from printing without the authentication. So I sent it over went through MSVR, sent it over to BlackBerry, and BlackBerry concluded that it was, of course, undesirable behavior, but it wasn't practically exploitable because, and I quote from them, printing does not succeed as a connector does not have a BlackBerry account info and token needed for printing. Didn't have the device, so I couldn't really test that aspect of it, but still, it was important to send it over to them because it could very well be a pretty big security issue. If you can bypass the authentication and just print arbitrary files to a device, obviously that's a security issue. But they did the research and they concluded that you couldn't practically exploit it because of this. So that was, even though it wasn't a successful security issue, it was something that I think that their team will keep in mind from now on. And it definitely was a good case study to think about. Even if something looks really exploitable at one point, there may be some flaw to catch you at the end. So I thought it was a good case to share with everyone. So some of the lessons that we learned through this presentation. Vendors range greatly in the capacity, and it's not necessarily correlated with size. You could have small development teams, very responsive, others have day jobs. Some big companies effective in established procedures, but bureaucracy could ruin the time you have with them. Setting limits are important. Sometimes through MSVR there's dumps hundreds of bugs through whatever means. Maybe they find one vulnerability and go test it on all our websites. Like David was saying, we don't have a whole lot of resources to coordinate all those bugs, so unless it's a high severity bug, we're going to have to make some accommodations.
And we had one guy who wrote a really effective tool that found thousands of bugs, and he wanted us to manually report each one of them. So that's not going to work. So we set him up with his own reporting mechanisms so that he could get those bugs to the people that needed them on his own time.
So why you should run your own MSVR. Give employees a standard end-to-end process for getting the bugs coordinated and fixed. A lot of times, like David was talking about, it's not just security researchers looking for bugs. A lot of times it's product teams, and they're not really experienced with security research, so they don't know the avenues they can go to get these things fixed. So MSVR definitely provides, or your own MSVR if you're a vendor. If you want to run your own program, this could provide your own employees with an avenue to get bugs fixed in third-party software that your platform frankly depends upon at some points. Another thing we learned, intercompany bug reporting. We can make it coordinated and efficient, cheap to run with high ROI. Boost employee morale. I definitely, in my free time, Microsoft, that's not my main job obviously, but I like finding bugs and reporting them, getting them fixed. And secure the ecosystem. Your product likely depends on something. And David to talk about what we'd like to see more.
Yeah, so I already mentioned we'd like to see people identify their contact information. We'd like to see them publish crypto information so that we can talk with you securely. And it's really important that there is some way to get to a person quickly who understands security. So whether that's telling your support rep that if you hear some keywords like vulnerability, please escalate to tier 3 or to a product team person, or whatever it is, make sure that the people who are going to be your front end know how to get security issues to the right place, because a lot of companies, the one guy doing sales knows nothing about this and just gatekeeps everything and doesn't let security issues get through to the people who really want to hear about them. So please find a way to get that line in place. Most people don't know enough about security to try and abuse that if you're worried about that. So just tell your salespeople if somebody mentions vulnerability, pass it along. We also like clear communication, like respond when we send you something, tell us what you found in your investigation, what's affected, did you repro it successfully, do you agree with the severity? Tell us about the release date. We don't need constant on-track status updates, but if you should slip your release date, please let us know. If we're going to be credited, we'd like to be asked. Microsoft will ask researchers to report to us what they want as a credit. We'd like the same from other companies. And close out on the issue and do something about it, fix it properly, and call it done. Ideally, we'd really like to hear that you've updated your company's development processes so that issues like this will never happen again. Unfortunately, not too many companies will actually do that, but that's what we really think should happen. Going along the same line, don't just fix the specific point bug we reported to you. Think broadly about what might be related. Fix all the related bugs, and don't drag your feet. We understand that software engineering is complicated, especially if you're trying to fix a wide class of issues, but don't drag your feet. Do it relatively promptly. We're Microsoft. I don't think anybody thinks that we're the fastest company in the world at fixing things, but we know how long it should take, and so when we report to others, we know when you're dragging your feet, and we know when you're actually responding promptly. Well, that brings us to the end. Do folks have questions?